From flying horizontally to being able to hover, it revolutionized aviation. From duplicating by hand to creating hundreds in minutes, it changed how we copy. And from playing in the background to taking center stage, it rocked the music industry. They were all inventions of the 1930s, a decade of challenge and hardship that inspired ideas like never before. The helicopter, walkie-talkie, and the electric guitar were all inventions that shook the world. It was invented decades before the cell phone and is still used today to communicate with soldiers on the front line, workers in the wilderness, and even with your friend down the street. Exactly as its inventor intended. 1933. A team of geologists tramped through a remote forest in northern British Columbia. Their only lifeline to civilization was their radio operator, Donald Hings. He knew Morse code and could communicate with head office. But Donald also completely embraced new technology.
He was a scientist, an untrained scientist. He didn't have a formal education, but he thought like a scientist. He was always finding problems that perplexed him. And then he would tackle those problems by inventing some crazy contraptions.
The geologists finished their job and prepared to head back. But there was an unexpected problem. Donald learned that they were stranded. Bad weather had grounded the plane that was supposed to collect them. So to get back to civilization, the team decided to hike through treacherous terrain.
Having to trek out on foot illustrated very personally to him how remote these locations really were, how lost these guys were if they didn't have that umbilical cord back to home office.
At home, Donald could not stop thinking about the experience. He wondered if it were possible to build a two-way radio anyone could use, without a middleman and without learning complicated codes. In the 1930s, it was much easier to send a radio message in Morse code than trying to radio the human voice.
It's not enough just to tell that somebody is speaking or not speaking. You actually have to make out the sounds and the words. And so to do that required a lot more technology than a simple Morse code set.
But the technology was huge, required lots of space, and was impossible to transport in a backpack.
The technologies for doing voice radio were well understood at the time. They were just too big and too clumsy to be useful for his application. So you start with that. You start with the radio sets that you do have. They're big, so you miniaturize them. You get them as small as you can.
So Donald had to miniaturize the radio. But at the same time, boost the power of its signal so voices could be transmitted clearly over a distance.
To make a voice signal come through clearly, you need lots of power, and to have lots of power, you need a big radio. And so it was just at cross purposes to the whole notion of portable voice communication.
Donald realized he would have to reinvent radio circuitry. The complex wiring used to join radio waves to a voice signal would have to change. He also had to find a way to reduce the number of glass vacuum tubes that controlled the flow of electricity within the circuit. Through trial and error, he created one small vacuum tube that previously did the work of 4 tubes. This meant that the radio wave could go through the tube at the same time as the voice signal, creating a super boosted, clear sound. Donald then began working on shrinking other components and experimented to find the right antennas and wavelengths.
Accomplishing all those things at once was the problem that my grandfather solved. It wasn't just a single invention. It was a very complex invention that had many, many different parts that all added up to what was at the time a really cutting-edge piece of complicated technology.
When Donald showed his prototype to his bosses, they saw huge potential.
All right, let's give this a try.
But the real test was to see how Donald's radio worked in action.
I don't really know if he would have been nervous as opposed to excited. I mean, you know, sure, it's his job. There's a certain expectation that he's going to accomplish things, but I think he was granted a certain amount of leeway because you're doing something that hasn't been done before. You know, your bosses, if they're halfway smart, are going to realize that, you know, this might not work perfectly the first time.
He moved deep into the bush.
Testing.
Testing.
I hear you, Donald. I hear you loud and clear.
Minimal static.
Testing.
Maximum clarity.
Testing.
I hear you, Donald. I hear you.
He always had this kind of a skip and a clap, and he would say "yeah" when something he got it working just the way he wanted it to. I imagine that he probably gave a very big, loud, and excited one when he got his first radio sets working.
Testing.
Donald's invention meant he no longer had to work in the field, so he had more time to work on ideas back at base, where he made modifications to his two-way radio.
It was capable of sending out a voice transmission that could be picked up by the next nearest radio camp so that signals could be relayed all the way back to home office.
During World War II, it was used with great success by the Canadian and British military. The device also got a new name.
The walkie-talkie was named by journalists during the war when they saw some of the early radios that were being used, and it was like, so you can walk with it and you can talk with it. Quite obviously, a walkie-talkie.
The walkie-talkie revolutionized military communication. Over half a century later, in 2001, Donald Hings received an Order of Canada for saving countless lives on the battlefield and in the bush. Other inventions of the 1930s. 1938, the beach ball, fantastic fun at the circus and the ideal ball for the beach. 1936, the Phillips head screw, also called the crosshead. It created more torque and tighter fastenings. Perfect in power tools on the assembly line. 1932, the Dynasphere. Powered by gravity and billed as a breakthrough in spherical locomotion, people lined up to watch, but not to buy it. Whether going through narrow canyons or hovering over a city, it's the most nimble and versatile of flying machines. But producing the first successful, mass-produced version took decades of planning and persistence by its inventor. In 1931, Igor Sikorsky, an aircraft designer from Russia, had only been in the US for just over a decade, but he was already well known. He had just invented the largest commercial airliner of the era, the Sikorsky S-40, an amphibious plane that he proudly promoted as his flying boat.
The ship may very comfortably seat 40 passengers with excellent accommodation, dining facilities, washrooms, even a little bar.
For most inventors, a flying boat would be the achievement of a lifetime. But Sikorsky had an even bigger dream. He had been obsessed with a different type of flying machine since childhood. He first saw it in one of Leonardo da Vinci's sketches, and then read about it in a Jules Verne sci-fi novel.
Jules Verne's book described the helicopter in uncanny detail, and primarily its capability of hovering, motionless in the air, dropping a line and saving people from sinking ships and all, I think was the inspiration that started that love affair between the helicopter and Igor Sikorsky.
Sikorsky grew up to become Russia's leading aeronautics engineer, a genius at designing airplanes. He also tried to build a couple of helicopters, including this strange contraption in 1910.
The first one was a total disaster. The second one could barely lift itself off the ground, but incapable of lifting the weight of a man.
Sikorsky's 25 horsepower engine was not nearly powerful enough to overcome the force of gravity.
My father then intuitively began to realize that the challenge of the helicopter was going to be even more difficult than that of a conventional fixed-wing aircraft.
Sikorsky put his helicopter dreams on hold. He left Russia during the Bolshevik Revolution and emigrated to the US. Then, because of the success of his airplanes, he decided it was time to try to design the helicopter again. A lot had changed over the intervening period. Metals had become more lightweight. There had been breakthroughs in aerodynamics. Engines were more powerful, and other inventors had been trying to design and fly their own helicopters. But their designs were complicated, with multiple rotors. And nobody had yet worked out how to solve the huge problem of torque, where the motion of the spinning blades made the helicopter want to rotate in the opposite direction. But Sikorsky had a completely different design in mind.
He insisted on creating a totally heretical, totally impossible, impractical solution, which was to drive one single main lifting rotor and counteract the torque with a tiny little rudder rotor at the end of the fuselage.
Sikorsky outlined his design idea. 3 blades mounted horizontally on a single rotor would be powered by the engine to generate lift. Another, smaller, single blade mounted vertically on the tail would counteract the main rotor to prevent the helicopter from spinning in circles. Critics thought this design was far too simple, but Sikorsky still applied for a patent. Because of the Depression in the US, the United Aircraft Corporation was forced to shut down the airplane division where Sikorsky worked. But he saw this as an opportunity and persuaded the company to give him a small budget to continue work on his helicopter idea.
The winning argument was when Igor Sikorsky paused for a second and said, "I am convinced that the helicopter will prove to be a unique instrument for the saving of human lives."
In the spring of 1939, Sikorsky built a flight training device to develop and fine-tune the helicopter's control system. Later in the year, he built a movable test stand powered by a motorcycle engine to test his rotor blades, which led to a crucial breakthrough. Sikorsky discovered that he could control the helicopter's movement better when the rotor blades were attached to a device called a swash plate. Tilting the swash plate forward decreased lift at the front and increased it at the back, which in turn pushed the helicopter forward, a process called cyclic control. In September 1939, Sikorsky had finally completed a helicopter prototype, the VS-300, a simple framework of welded steel tubing.
Very good. Very good, gentlemen.
With an open framework, you could change anything. Quite literally, with overnight, you could take one hacksaw to take off some part you didn't like, and a small welding torch to weld it on to a different part of the helicopter.
The VS-300 had 3 blades in the main rotor and a single blade as the tail rotor. Both were powered by a 75 horsepower engine. Sikorsky prepared to take his first vertical test flight, wearing a fedora hat which he called his crash helmet. Making this invention fly was Sikorsky's riskiest experiment.
He was teaching himself how to fly this very capricious, unstable machine at the same time that he was conducting his first flight tests.
Sikorsky was bold, but not a fool. For this first test, the helicopter was tethered to the ground with heavy ropes. It was fortunate too, because when the prototype took off, it was very unstable in the air, bouncing and tilting erratically. Sikorsky spent the next 3 months refining his cyclic pitch control in order to ensure the machine was more stable.
We are ready to go.
But in December 1939, he suffered a big setback. With another test pilot at the controls, the modified prototype was caught in a gust of wind. The machine rolled over and its rotor blades smashed into the ground.
When that happens, you have one shredded rotor system and a very badly bent helicopter.
Sikorsky thought the problem lay with the tail rotor, and he started to experiment with different designs.
I remember my father coming home, unhappy, sometimes very frustrated, but never, ever frustrated to the point of saying, "I'm giving up."
He tried a variety of configurations for the tail of his prototype, but eventually he returned to his original idea of a single vertical tail rotor. The key, he realized, was to position it so that it was not compromised by the wash from the main rotor. 2 years after the first test flight, Sikorsky believed he had finally solved the problem. During this test, he'd attempt flight with no tethers and full control in all directions. It had been 31 years since Sikorsky tried building his first helicopter in Russia. Finally, he and his team had proved that this kind of flight was possible, and it revolutionized aviation in the process.
I know that my father was very pleased because when he came home, he had again one of these big, wide grins on his face. And he did say to the children at that time and to a rather interested mother, yes, it has flown. Today we flew it. I can say with a fair amount of conviction, he never, ever gave up that dream of building a helicopter.
3 years later, the helicopter achieved what Sikorsky had always dreamt it would do. In April 1944, the US Army flew a helicopter into Japanese-held Burma to rescue soldiers caught behind enemy lines.
The helicopter has become, as predicted by my father, it has become a unique instrument for the saving of human lives and speaks for itself.
Igor Sikorsky became a household name. He was awarded the Presidential Certificate of Merit. And 70 years after his first free flight, Sikorsky's innovative design lives on in most of today's helicopters. also invented in the 1930s. 1936, the air-conditioned suit. Bellows under the foot pumped cooling air all the way up to the hat. But the idea proved to be just hot air. They are called money grabbers and are considered one of the most irritating machines ever. But at one time, driving was even more annoying before the parking meter was invented by a newspaperman in Oklahoma. In 1931, Carl McGee ran the Oklahoma City News. He was always on the hunt for a good story, but there was a reoccurring one he was fed up with. The city's never-ending parking crisis.
From the turn of the century, or early 1900 to the mid-1930s, the number of automobiles in Oklahoma had increased by 500%. But the number of parking spaces hadn't increased.
Drivers were only supposed to park for an hour, but everyone was breaking the rules. Office workers parked for their entire shift, taking up the precious spaces all day long.
These people would come to work at 7, 7:30, 8 o'clock in the morning. They would stay until 4:35, 5:36 in the evening and not move their cars,
leaving everyone else circling, on the lookout.
The retail merchants were up in arms over this because all of these office workers were taking up the parking spaces that their customers then couldn't use.
The city's police tried to solve the problem by marking people's tires. But office workers found a way around that, too.
People would come out and maybe move their car 6 or 8 inches, so then the chalk mark on the tire wasn't in the same place where the cop had made it an hour or 2 hours earlier.
A desperate chamber of commerce formed a committee to solve the problem, and they knew the perfect man to be its chair.
In the early 1930s, Carl McGee was the editor of one of the daily newspapers in Oklahoma City, the paper that was owned by the Scripps Howard Company. Now, McGee had lived in Oklahoma previously. He was, besides a newspaper editor, he was also a lawyer.
Carl McGee was used to dealing with difficult issues.
Carl McGee approached any problem head on. I don't think there was ever a problem that he didn't think that he could surmount. He went straight at the problem with only one goal in mind, and that was overcoming that problem.
And the parking problem was no exception. McGee thought about it constantly. Then he got an idea. What about a machine that took your money, but instead of buying a treat, you bought a piece of pavement to park your car? McGee realized he would need another critical component to make his idea work. A timer that told drivers when their parking time had expired. He tried to build a device at home on his own, experimenting with parts from an alarm clock. But he was not an engineer. He needed professional help to get his idea off the ground.
McGee was also somewhat of a tinkerer and an inventor, and not really an engineer, but he had friends who were engineers.
He had connections at Oklahoma State University.
As many conversations as he had with the professors and with students at Oklahoma State University, he never talked to them on the phone. He would insist on driving from Oklahoma City to Stillwater to meet with them, to see them, to talk to them in person.
He visited the head of the engineering department, Professor Holger Thusen.
I've got it. There would be a coin-operated timer.
Thusen was intrigued and volunteered to find the solution himself. However, it was not as simple as it appeared. There were a lot of requirements to make a parking meter work.
It had to be simple to operate. It had to be inexpensive. It had to be hard to break into so that people couldn't steal the money out of it. It also had to be foolproof in that you couldn't use a slug in it instead of a nickel, and it had to operate in all kinds of weather, in the heat of the summer as well as in the cold of the winter.
And that clock would be attached to a timer.
Thusen and McGee did not have time for tinkering, so McGee made a suggestion. Enlist Thusen's engineering students and turn it into a competition to give them an incentive.
He reached in his pocket and pulled out 5 $100 bills and gave them to the engineering professor at Oklahoma State University and said, "Here's the money for the contest. Let's make it happen. Let's make it work."
At the end of the term, the trainee engineers presented their creations.
This will never work.
None of the designs were perfect, but McGee and Thusen chose 3 prototypes that came closest to meeting their criteria. They used these designs as the basis for further improvements to their own device. In the summer of 1933, Thusen and a fellow instructor unveiled a prototype nicknamed Black Maria, and it worked like a dream. Inserting a coin and turning the knob compressed a spring, which made the coin drop. As the spring released, it also moved a pointer that showed how much time was left. As the spring slowly returned to its original position, the pointer edged back to 0. McGee finally had a machine that worked.
Ladies and gentlemen, the Park-O-Meter.
And he successfully filed for a patent. The parking meter was ready for the streets, but it would take a fight to get it there.
Several lawyers said, "Oh, you can't do that. You cannot charge people to park on a public street that was built by public money. It's double taxation. You can't do that."
But the city council won in court, and in July 1935, people started paying for parking in Oklahoma City. Drivers were not pleased. But the local government generated $60,000 in the first year alone, a bonus during the Depression. And suddenly cities everywhere were installing their own meters.
I don't think there's a city in the world that you can go to that you don't have to feed a parking meter to park. And people around the world can thank Oklahoma City for that privilege.
And Carl McGee. His invention wouldn't win a popularity contest, but at least everyone pays, no matter who they are. And it's a small price when you consider the chaos that came before it. It was the greatest breakthrough in printing since the printing press in the 15th century. What was even more staggering was it might never have been invented if it wasn't for the unusual genius of Chester Carlson. In the mid-1930s, Carlson was bored just pushing paper in a New York patent office. However, it was the Depression, and he was happy to have a job because he knew what it was like to be poor.
He had the worst childhood in history. His father was an itinerant barber who had arthritis of the spine and also tuberculosis and was unable to work. Chester began working to support his family when he was 8 years old, and by the time he was in high school was the main financial provider of the family.
But as an adult, he'd had a difficult time finding a job during the Depression in the US, even though he had a degree in physics. His job was to ensure that every patent document was copied a dozen times. Either copied out by hand, photographed on an expensive machine, or mimeographed using messy, wet ink.
Photography could not provide the answer to the office copying problem, because in the more than a century that photography had existed, nobody had figured out how to print a photograph on plain paper. You needed chemicals, you needed specially treated paper.
After work, things didn't improve for Carlson. He went to evening classes, but couldn't afford textbooks. so he had to copy thousands of pages by hand. He also had arthritis similar to his dad, so was in pain all the time.
When his hands hurt so much that he couldn't write anymore, he would often go in the library and look for clues as to how a copying machine might be made.
Carlson thought that the giant machines and the wet ink could be replaced by something cleaner and more efficient, using light and electricity. An idea that developed further when he read of a photoconductor, a substance that conducted electricity when exposed to light and did the opposite when left in the dark. Carlson's theoretical mind began to evaluate. What if he could put an electric charge through an image, then use a photoconductor to drain the charge out of the lighter parts, leaving only the darker bits charged, so they attracted the ink powder? It was the spark of an idea, but how to test it? Carlson started experimenting with different photoconductors and discovered that sulfur was the perfect material. But he had difficulty working out how to bond the sulfur to a metal plate to create a uniformly charged surface.
Finally, he hired an assistant, and the assistant very quickly was able to perform the simple demonstration experiment that Carlson had laid out for him, that Carlson himself had been unable to do.
The metal plate had been successfully bonded with a sulfur coating, so Carlson was ready to try making a copy. He created a simple image by writing the date and location on a glass slide. October the 22nd, 1938, Astoria, New York. Carlson then created an electrical charge on the sulfur-coated plate by rubbing it with his handkerchief. He placed the image on top of the electrically charged plate. He then shone a bright light through the image onto the plate. The sulfur photoconductor drained the electrical charge out of the lighter parts of the image, in this case, everything except the words. The darker part, the actual words, retained their static charge and attracted ink powder. The result? The ink powder was attracted to the areas that were in shadow, recreating the original image on the metal plate. Finally, Carlson used an iron to soften a piece of wax paper. The warm wax stuck to the ink powder, transferring the words from the metal plate to the wax paper.
The world's first photocopy is a little bitty piece of wax paper. There are dots in the background. The writing isn't very distinct, but that's it. It's the world's first Xerox copy.
Carlson's idea was so revolutionary, it was hard for mere mortals to understand his achievement.
Honey, look! Look! It worked!
I'm happy for you, Chester.
But he was driven by just this determination to fulfill the ambition that he'd had since he was a child, which was to become a great inventor, to do something that would make a mark in the world, that would make a fortune for himself.
At first, corporate America was not impressed either. At least 20 companies rejected Carlson's idea. It took almost a decade to persuade anyone that his patent would be successful. In 1946, a photography company called Haloid bought into the technology. Carlson's invention acquired a new name, xerography, which means dry writing, and the Xerox empire was born. Carlson became a multi-millionaire, and his invention was a hit with office workers everywhere.
Carlson is fascinating not only because he's a solo inventor, which is a great rarity, but also because his invention has never been topped. We still make copies the way he invented in the 1930s, and that's not true of almost anything else that we do.
By 1968, Chester Carlson was one of the wealthiest men in the US and happily remarried. But he never forgot his humble roots and gave away most of his fortune to charity. Other inventions of the 30s. 1933, motorcycle goggles with self-propelling wipers. The invention kept bugs and rain out of your eyes, but it never caught on. And 1936, the trampoline, created by gymnasts to train tumblers. Its popularity exploded as families wanted some of the fun too. It's the heart of rock and roll, a sound that defined the 20th century. So it's hard to believe that guitarists used to blend into the background until one of them made it his mission to stand out. It's 1929 in LA, where Hawaiian music was all the rage on the vaudeville circuit, and where a dapper young guitarist named George Beecham was attempting to make a name for himself.
If you look at a picture of George Beecham, you see a very urbane, sophisticated, very, very well-dressed, handsome young man. He looks very much the part. You know, he was a partier. He loved a good time. He's very generous, and he made friends.
In George's day, bands were getting bigger and louder. That was a problem for the guitar players, because they were getting drowned out by the other instruments. Unless musicians such as George found a way to increase their volume, they would never make a decent living.
Volume was everything, because if you can't be heard, you're not worth as much. You want to play loud so people could hear you, and you want to play loud so that you could be somebody in the band rather than the robot in the back plunking out the rhythm.
George tried playing into a microphone and turning up the volume. But that created nasty feedback. So George tried something else. He went to a local violin shop where he and the owner experimented, inserting 3 aluminium cones into the body of the guitar. This made the instrument resonate more loudly. The new guitar, known as a tricone, was a hit with musicians. But George wanted something even better. He thought the solution was electrical, not mechanical, and that another kind of music device might contain the technology he wanted: the phonograph. Invented in the late 1800s, it worked using electromagnetics. Grooves in the record caused a needle to vibrate. That vibration was picked up by a magnet wrapped in coils of conductive wire. This electromagnetic pickup translated the vibrations into electrical signals, which were sent to a loudspeaker that would boost the sound to any level. George was excited. What if he could build that same concept into a guitar? To see if the basic idea worked, he built a 1-string test unit with a piece of wood. Then he removed the electromagnetic pickup unit from his record player, took it apart, and incorporated it into this crude instrument. The results were promising. He went on to experiment with different shapes and sizes of magnets. He decided that a horseshoe-shaped magnet worked best, because a powerful magnetic force was created within the horseshoe itself.
He represents that sort of American Yankee ingenuity who's going to fix anything with a pickaxe handle and some baling wire. And he had that kind of can-do attitude.
George then enlisted a friend to build a proper guitar prototype. Over several weeks, a unique new instrument took shape, called the frying pan.
They called it the frying pan because it looked like a frying pan, but the shape owes a lot to the ukulele and the banjo, which were the stringed instruments of the time.
Then the pickup devices that George had designed were inserted. 2 horseshoe magnets placed end to end. The guitar strings would be threaded through the arms of the horseshoes, through the magnetic fields. When a string was plucked, it would disturb these fields. The disturbances translated into electrical currents in the nearby coils of wire. That current traveled to a loudspeaker. The result? A louder, more distinctive guitar than had ever been heard before. In order to manufacture more guitars, George turned to another friend, Adolf Rickenbacker, who ran a tool and die plant.
He goes to Adolf Rickenbacker because Rickenbacker is a craftsman, and Rickenbacker is a guy that works with his hands. George Beecham is a musician and a thinker and a dreamer. Rickenbacker is a straight shooter and a businessman.
October 1931, they formed a new company, Electro String. But there was an unfortunate twist for George Beecham. His name didn't look anything like it was pronounced. Bad for marketing. But Rickenbacker's name was already famous because his cousin was Eddie Rickenbacker, a legendary flying ace. So the guitar was sold as a Rickenbacker.
George Beecham is the invisible man in the story of the electric guitar because he couldn't put his name on the guitar. He invented it, but his name wasn't on it.
Soon, everyone was trying to build and sell their own versions of the electric guitar. George and his partner decided it was too expensive to fight the patent infringements.
And they describe in their advertising materials, it was a versatile sound. You could make it sound like whatever you wanted.
As it turned out, there was soon enough business for everyone, because guitarists soon realized that George's invention made them the stars of the show.
The electric guitar really is the sound of the 20th century. If we listen back, it was the sound that propelled rock and roll was that revolutionary event in popular culture that we still live with. The electric guitar didn't shake the world, it rocked the world.
From Hendrix to Townsend, from Lennon to Richards, anyone who's plugged in and tuned up owes a piece of their legacy to George Beecham.